Excuse me. All right, recording's on. We're good the right time this time. All right, so today we're going to have one last week when we just talk about using loops and arrays and such. And so today we're going to go through one last problem in that mode before we move on and before I give you a project to do. Yay. So what we have been doing is more or less just trying to get used to the logic of using arrays and the logic of using loops and putting everything that we have done into the same place, right? So, so today we're going to look at, I think it was homework 2, the extra credit problem off that homework. I think only one person opted to do it, so I figured it'd be a nice one to go back to. So, for those who might have missed it, the homework problem said that we want to generate 1,000 random numbers. So make 1,000 random numbers using the numpy ramp function. So that it will generate a random number between 0 and 1 every time that you make it, some decimal value between those two. And I wanted to count how many of those 1,000 numbers were between 0 and a quarter. Sorry, count number of random numbers that lay between 0 and 0.25, 0.25, 0.5, 0.5, 0.75, 0.75, and 1. That's what I wanted to count. More specifically, you could say, if you have a random number u, if u is greater than or equal to 0, less than 0.25, 0.25 less than or equal to u, less than 0.5, less than or equal to 0.5, 75, there we go. So find how many random numbers do you make fall into each of those categories. That is the trial. If I remember correctly, that was the homework problem. So that's what we're going to look at first. And then if we have time, we're going to say, okay, now I don't just want to know how many there were. I want to know exactly what they were. I want to store them all. So I want to put them all into an array somehow. So let's play the game. All right, so throw a comment at the top because that's always a good life choice. Okay, so we're going to essentially just see how the random numbers from ramp are distributed. In theory, ramp is a uniform random number generator, so we should have an equal or close to equal proportion in each of those 4 categories because they're equal in size and equally spaced. So we know that we will need ramp. So from numpy random import ramp. So we know we need that. And then we need to count things up. And this is the trick. We know that we need to do this 1,000 times. That's easy. I can say how many numbers do I want to make. And I can just say for I in range and num and yeah, get 1,000. And then now I have this construct that'll run around 1,000 times, right? That's the easy part. So the question is, if I generate a random number, like that, assuming I remember how to use ramp, what do I do now? If I want to count things, what do I have to control? Where should I go from here? I have that random number, but what do I do with it? Yeah. Right, right, absolutely. So, I want to ask, the fact that I have conditions as to what different intervals I'm counting, and the fact that who want to know a particular thing about my random number, it implies that I want to ask a question. So you ask questions with an if statement. So if you can do this a couple of different ways. I'm going to say if random value is less than or equal to 0 and random value less than 0.25. I'm just doing this so it's more explicit. You can do it in other ways too. And I can keep on writing if statements like that. Say if random value, sorry, that's not, less than that should be a greater than equals 0.25 and random value less than 0.5. I can keep on doing this, right? But I have to put something into that, into those if statements to make them do something. So what I'm going to do is I'm going to make what's called a counter. So I have these if statements. They let me have some control as to what the program does in different scenarios, meaning if the random value is greater than or equal to 0, less than a quarter, greater than a quarter, less than a half, blah, blah, blah. But what a counter does is it's a variable that I use for counting. That's the only reason why it exists. So go add some comments here, see if we can explain this. So I'm going to make a variable. I'm going to call it counter 0 to 0225. So this is the variable that I'm going to use to count the random values that lie between 0 and 0.25. There's nothing special to it. The only reason why the only reason why I'm calling it something different is because it only has one purpose, and that is to count. So the only thing I'm going to do to this is add it to itself. Well, add one to its value. That's probably a more clear way of saying it. That's the only thing that I'm going to do with this variable. So every time I go through this loop and my random value lies in this range, the code will increment the value of that counter by 1. So this is like a really, really handy trick, right? If you ever want to keep track of something, just set a variable to 0 up before you need it, and then just increment it whenever you need to keep track of whatever the quantity is. It's just really straightforward, so it's really handy. And I can do it for all these, right? So I can copy that a few times. And I'm naming these counters so I know what they're counting. I just have to add in the appropriate ones. There we go. So does that make sense to everyone? You all pretty happy with that? Potentially, maybe. Yeah. Yep. So once I generate a random value, or either I generate one here and I save it as random value, comes down, it goes through these if statements. So ask, okay, is it greater than or equal to 0, and is it less than 0.25? Okay, great. Increment this, counted by 1. This part of the if was true, so it skips everything else, comes back up here, but gets a new random value, and just keeps on doing that test. Does that make sense? Cool. So once I have all this, one thing I can do, oh my goodness, here we are. One thing I can do is, once I'm all done, find the proportion that, find what percent of all the random numbers generated lie in each interval, because that's like an interesting statistic, especially if we're looking at a uniformly distributed random number, at least what it should be. Then it'd be nice to know if it's actually distributing uniformly, right? So I'm going to say, let's give it to a variable, because that's better practice. So I'm going to find the proportion between 0 and 0.25. So that's just counter 0, 0.25 divided by the total number of values, right? Oops. You can do that for each of the ranges. And print that out. Cool beans? I guess amount is misleading. It should be proportion or fraction. You all happy with that? Any questions? Counters are pretty straightforward. Just a nice tool to know that you have. I'm going to try to run this and see where we end up. Well, that's interesting. Ended up with almost just everything in 3 ranges, and it's almost nothing from 0.5 to 0.75. Ramp is doing weird crap. Sure, I didn't screw up how to use that. Nope, that is how to use it. Okay, just make sure I'm not being dumb. So this is a kind of interesting answer. It's also something that this is definitely the kind of answer that you want to check though, because it is kind of weird. So if I look at these 3 numbers here, they should all sum up to 1, right? Because in theory, if I've added everything up right, the fraction that goes into each of these four ranges, if I'm making a number between 0 and 1, I should have 100% of them in here, right? So look at these 2 guys up here. It's a 6. Guy who goes to 5, so this is 0.506, the sum of these 2. And that's 0.506 plus 0.494 is 1. So I know that I have all of them there. It's just a really weird answer. So just for kicks and giggles, let's grab a couple more numbers. I'm gonna go for a million. It's fun. Wow. Apparently, this random number generator hates that third region there, or rather, it either hates that third region, or we add a logic error. So let's have a look, because this should be a uniformly distributed random number. The fact that it's not distributing uniformly is weird. So let's have a look. What do you guys see? What was the interval that wasn't getting any values in it? The third one, right? From 0.5 to 0.75. So so that's like this guy, right? So if this isn't incrementing at all, the next question is, so how would it increment? Well, it would increment if this if statement was true, right? Right, but if they're both the same, wouldn't they both run? Right, because it's only going to run, it's going to go to the first true branch of the if statement, and then it's going to skip the rest of them. So the fact that it's doing in this case is fine. It just means that this means that I need to do this correctly. Go from 0.5 to 0.75. And that looks much more better. Almost a perfectly uniform distribution between the 4 categories. Why didn't I? Yeah. Sweet, value error. That's an interesting one. Oh, the truth value of this array. Oh, instead of ramp I, use ramp 1. I think I generates more than 1 random. more than one random number. Whoa, nice. Oh, so the equal sign you use when you assign things is a single equal sign. The equal sign you use when you compare things is a double. Not that one, because that's a greater than or equal to, but like, I just saw one. Crap. Oh, never mind. Let's do this. So counter equals counter plus one. Counter equals 0 equals counter plus one. Counter equals, yeah. It's cool. Cool. So this is doing good things. Any questions about this code? All right. So for our next trick, we're going to store every single random number that falls into each one of those different intervals. Okay? Do we know how many random numbers will fall into each one of those intervals? No. We have no clue. We know what it should be, in theory. It should be 25% of whatever n-num is. But we know from just running the code right now is that it's not going to be that. It's going to be slightly over, slightly under. We can't predict how many values are going to be in each interval, and that's fine. So if we did know, we could just use numpy zeros and make an array of the right length, right? Instead, we're going to have to build an array or a list. Arguably, lists are a little bit easier. Do I want to do this right now? Yeah, we'll just use arrays. Okay, arrays are fun. So what we're going to do is we're going to build an array on the fly. We're going to start with an array. We're going to start with an empty array, and we're going to create a larger array from there. So let's play the game. Storage arrays. Okay, so when I make an array this time, what I'm going to do, I'm going to say what it's for. Then I'm just going to give it an empty pair of brackets. That empty pair of brackets means that it's an empty array, or an empty variable even. There's nothing in it. It just exists. It's a container with nothing in the container. That's it. What we're going to do is we're going to fill that with our values as we go forward. So make one empty storage array for each range. Then I'm going to come down here. I'm going to say, if I want to just store a value there, I could just say that, right? What am I doing? Random value. I could just do that, but that doesn't get me a list of values. That gives me a single value, right? I want more than one. So what I'm going to do is use the vstack command. Pardon me for a second as I remember if it's numpy or if it's not. It is. Okay, cool. So if I go back up to the top, I haven't imported numpy yet. I've just imported ramp. So we need to import numpy as np. I come back down here. So up here, the first time I did this, I only imported ramp. I said from numpy, import a single function. Now I want to import just everything. So I'm going to so do that. Then I can come back down here and say np.vstack. I'm going to ask it to stack those two things. Just need to put the second one in brackets. So what the heck's going on with this? Let me print it out and let's see if we can figure it out. Did I figure out how to use it? Hang on. Oh, it's two of those. Okay. Oh, bother. Hold on. I guess it'd be more useful if I didn't have as many random numbers. 50. There we go. All right. So this is what it printed out. If I go back to my code, I start with what's called and look at this command. I have whatever was in this array, and I have whatever my new value is, right? So in this array, we said started as empty, or if you saw me put something in there as just 0. So what happened? It started with just one value, and I ended with a whole bunch, of values. Some is called, and all of them except for the first value look like a random number. What happened? I mean, in the short term, it looks like I just took a whole bunch of random numbers and smashed them into the array, right? I took whatever the array was that I started with, and I added things to it. And that's exactly what happened. What vstack does is it creates a new array by stacking two old arrays on top of each other. So I started off with 0 or an empty array. I took a random number, and I stacked them on top of each other and said, that's my new array. Then I went around again, got another random number, stacked that with what I had. I get a new array. Stacked another one, stacked another one, stacked another one. It's called stacked all of them up until I got that. Does that make sense? So the vstack command is a way of concatenating values together in one large array. So I take a whole bunch of small things, I smash them together, and I have one array now. So for example, I could take that array and I could say, just print the first value of it. And well, it's an array. So the array index of 0 gets me out the first value, right? An array index of 5 would give me the 6th value, right? So by using this vstack command, I've made something new of completely arbitrary size too. It's like I can increase nnum to 150, assuming I didn't get rid of the print command that showed me what was going on. Could increase NM to 100 to 150. And the thing would still work. There are 150, which 150 O's over 4, anyhow. Random numbers, which call all the ones that fit in that particular category. Make sense? Sort of. What doesn't make sense? Okay, so we all on board with this sort of thing? Yeah, yeah. Yeah, let's see if we can work it out in diagram. If well, ignore the power spheres here. So you start off with a array that's one block. Can be empty, can be 0. I changed mine a little bit so that it starts with an array that is just one cell, and that one cell is 0. That's your storage array as it starts off. So storage array. All right. So you start with that. Further, which call later on in the code, you generate a random number. So whatever, right? And these two are separate from one another. So starting off, you have a storage array and a random number, and they're separate things. Yeah, cool. All right, so what happens when you do the vstack command? So imagine that I run vstack. So and vstack requires 2 sets of parentheses for some reason I have not fully figured out. So I run that command there. What it does is it takes my storage array, takes this random value, and it sticks them together so that I end up with one array that looks like that now. Yeah? You following my PowerPoint scribbles? Takes these 2 separate things, it stacks them, combines them, and now that single array here, that is now a storage array. And it's now an array with 2 cells in it, not just one. So that's like sounds like super cool. Then if I wanted to, I can come back up. Let's make a second part here. I'll come back up. This is now storage array. Get rid of these. This is now storage array. So I come back, I run the command again. So now I'm taking that value of storage array, stack another random number, stack another random value in there. Now I have a 3-cell tall a 3-cell tall array that is called storage array. Does that make a little bit more sense? So so what VStack does is just takes another value. I have to make it into an array. That's why these square brackets are there. It stacks it at the bottom of whatever other cells I have and combines them into a single array. And whatever's on the right, stored on the left. So it stores all that as storage. I do that again and again and again and again and again and again. So I just have this huge array that I can make of any size that I want, which is super cool. The only downside with using VStack, or rather any sort of concatenation, which is what VStack does, is that I can't start with something empty. I forgot about that. It's list. I can start with empty things. With VStack, I can't start with an empty array. So I have to make an array that has something in it. In this case, I used the empty.array command. Essentially, it makes me make an array, and I have an array that has a 0 in it. So to use array in order to make arrays, it just open paren, open square bracket, and anything inside of the square bracket is your array. Close square bracket, close parenthesis. And I can do that for all these. If I wanted those arrays to start with 5 in them, I could just put a 5 in there. If I wanted it to be a 3, or if I wanted to have 3 elements in there, I could put a whole bunch of elements in there, just a whole bunch of values in there, just separated by commas. But I want a single element, and I want it to be something that I know, so I'm just going to put a 0 in for all of those. All right. Cool. That's one way to do it. The only downside about collecting numbers this way is that you end up with, well, one cell that doesn't correspond to anything, right? But you know what cell it is. You know it's the first one, so you can skip over. So you can skip over it if you ever need. It's not that big of a deal. For completeness, though, let's just add the storage element to each one of these. All right. Any questions on that part? Cool. Let's go to this print statement. So now I have all numbers that fall into each one of those intervals. That's fun. Oh, we got 10 more minutes, so I'm just going to go over how to do that in a little bit cleaner way. So another way to do this would be to use a list. A list is another Python construct. It's similar to an array. You just can't do math with it, which is really annoying. That's why we haven't really talked about it. But what you can do with the list is start it from empty. So I'm just going to start that list as an empty thing. I'm going to use what's called the append command. So append does with a list what VStack does with an array. It takes whatever number you're appending and smashes it on to whatever you have. Okay, does that make sense? Yep. Yep. So I have list. So I have list example. When I append something to it, it takes whatever was in list example and adds that new value onto the end. The only trick is that this starts as an empty list, right? So there's nothing that add random value to. So random value just becomes what's the only thing that's in that's in the list. Okay. Assuming that I haven't forgotten how to use it. So if I go down and print list example, whoops, sorry, this is an old, there's a problem with the other one. 75 to 1, 5075. Okay, 02505, 751. I did a typo somewhere. Line 78. Or line 38. Storage 0751. Storage 0751. Oh, 01. That's it. Wrote a variable name wrong. All right. So that's what the list is. So this is my list that I just printed out. The fact that it's saying each value in the list is an array, it's because, well, it kind of is. NumPy makes arrays out of everything. So if you ever do something like this where you try to pull something out of NumPy and put it into a list, you have to tell it something. So there you go. You don't have to talk about this too much. I just want to show you what's there. So now I have all those random values in there. I don't have any extra values that I just had to stick in there. They all exist. All they had to do in order to get from where it's saying that everything was an array to here where they're all just numbers. Let's just tell it which value of the array to pick, and it's just the first one because there's only one value. Does that make sense to everyone, or do you want me to go back and kind of look at that again? I'll go back and look at that again. So right now I'm appending random value to the list, right? And this works the exact same way as we talked before with what's called VStack. A list is just a different structure in Python. It's like an array, it's just different. The differences are more or less some semantics. I'm appending random value onto that. However, when I run that code, this is when I print out the list. Well, this is good. I have all my random values, right? And each comma is a new random value. So random value, comma, new one. But they all say that they are arrays, which is like really annoying, right? All I want's that value. But if this is an array and it has one element in it, what is the address of that one element? What's always the address of the first element of an array? Yeah. 0. So I know the address of that value in the array. It's address 0. So all I have to do is go back to where I put the random value into the list. I say, when I print this out, it says that this is an array. So I just need to pick the 0th element out of that array, and I'll get a number. So I do that. Oops. Hope I can see this. And there I have my list of just random numbers. No extra arrays being stored in the middle of this list. Cool beans? Any questions on stuff we did today? Cool. So that's the magic of arrays and if statements inside of loops. They're fun, they're cool. I'll post this online shortly after class. You can look at it if you want. So that's all I got for today. Thanks for stopping by.